Okay, let's unpack this. You know that ultra crisp camera angle seamlessly cutting in from a blimp like miles away during the Super Bowl?
Oh, yeah. Always incredible to see.
Right. Well, today our mission for this deep dive is exploring the invisible tech that makes that magic happen.
Hmm.
We're looking at a spec sheet for a very specific piece of broadcast hardware, the DVIGear DVI-7348-RX fiber optic receiver.
Yeah, and to set the stage here, you need to know this isn't, the kind of tech you'd find in your living room.
Definitely not.
No, it's built exclusively for critical live production environments. Essentially, it acts as an optical translator.
Okay.
It sits at the end of a fiber optic cable, captures these rapid-fire pulses of light coming down a microscopic glass strand, and while it translates them back into pristine, uncompressed video.
What the industry calls an SDI signal.
Exactly, so a control room monitor can actually display the image.
Okay, let's unpack this mechanism a bit because the sheer capacity of this little box is just wild.
It really is.
It handles up to 12G SDI formats. And for those of you listening outside the broadcast world, that basically means handling ultra-high definition, uncompressed 4K video flowing at a staggering 11.88 gigabits per second.
Yeah, that's a lot of data.
It's like taking a massive multi-lane traffic jam of high-res video data and just compressing it down into a single lightning-fast lane of pure light.
And what's fascinating here is the reach that light gives you. Utilizing just a single strand of single-mode optical fiber.
Which is incredibly thin, right?
Yeah, it basically means firing a highly focused microscopic laser straight down a glass core that is thinner than a human hair.
Wow.
And this receiver can pull in that massive video feed from over 6 miles away. There's even an extended option that pushes that reach up to 25 miles.
Oh, wait, let me push back on that for a second.
Sure, go ahead.
Because, wireless technology is so prevalent today. I can stream a 4K movie to my phone over Wi-Fi right now. Why go through the massive headache of stringing 25 miles of physical fiber optic cable across a sprawling golf course instead of just beaming the signal wirelessly?
I mean, it sounds logical, but in live broadcasting, a single dropped frame is a disaster. Wireless is convenient, sure, but it's incredibly vulnerable to the environment.
Oh, like signal noise?
Exactly. Imagine 80,000 fans in a stadium, all trying to use their cell phones at once. That creates this massive wall of radio frequency and electromagnetic interference.
The RFI and EMI stuff?
Right. But fiber optics have a unique advantage here. They are entirely immune to that environmental noise.
Because it's enclosed.
Because the signal is literally just trapped light. So no amount of radio frequencies in the air can even touch it.
Okay, that makes perfect sense. You need an absolute guarantee of zero interference. But here's where it gets really interesting.
Okay.
The receiver isn't just a passive video monitor. It includes RS-485 and tally light control connections.
Yep, it's doing two-way communication.
Right, so a director in a remote control room can actively operate and signal the distant cameras. But how does the director send physical camera commands backward, up that exact same strand of light?
That is the real brilliance of this engineering. It uses different wavelengths, basically different colors of light, to send data in both directions simultaneously without colliding.
Oh, wow. So they just pass right by each other.
Exactly. So a director sitting in a trailer miles away is actively driving the camera without interrupting the video feed at all. And remember, because you're running cables up to 25 miles, these cameras aren't in cozy, climate-controlled studios.
Right. They're outside exposed to the elements.
Exactly, which perfectly connects to the physical design of the device itself.
Yeah, the spec sheet mentions it's housed in a rugged, die-cast metal enclosure with locking BNC connectors.
Those heavy-duty ones.
Right, the ones that physically twist and lock into place.
Mm-hmm.
So if someone trips over a cord, it doesn't ruin the entire broadcast.
Exactly. It is engineered to operate in the most extreme temperatures, ranging from negative 40 degrees all the way up to a boiling 185 degrees Fahrenheit.
So what does this all mean for you listening? It means the next time you're watching a flawless live event, remember the invisible backbone doing all the heavy lifting.
Absolutely.
For about $375, this compact receiver serves as the vital invisible backbone of demanding broadcast workflows, keeping the whole show running flawlessly.
And it leaves you with something pretty provocative to ponder.
Ooh, what's that?
Well, if a single strand of fiber can reliably carry massive 12G video feeds and complex camera commands across 25 miles of freezing or boiling terrain,
Yeah.
how might this rugged light-speed technology reshape other data-heavy industries outside of television broadcasting? Like, imagine what this could do for deep-sea exploration or even remote robotic surgery.